Hi, everybody. This is today is September 21st, and this is the meeting for the SIG architecture for Kubernetes. If there is new folks here that would like to introduce themselves, here is your chance. Jyoti, you've been around here. Mark, do you want to say hi?
Yeah, sure. My camera's not working today, but happy to be joining the meeting. Thanks, Dims, for involving us over here in AWS in more of these. I'm an SDM in the EKS data plane org, and just looking to get more context and more involved. Yeah, thanks.
Yeah, thanks, Mark. Hi, Wei. Okay. So, Jordan, looks like you have the first agenda and the only agenda for us. So please walk us through it.
Sure. I'm happy to share my screen, or you can pull up the links yourself.
I'll let you do that. I'll let you do
Okay.
that. Yeah. Let me make you co-host first.
Yeah.
Participants make co-host and stop share. Go for it.
Let's see. All right. Can you see my screen and see all the tabs?
Yep.
Yes.
All right, cool. So I think a year or two ago, we were talking about tracking regressions, and we had added a label to GitHub so we could put it on issues and pull requests that related to regressions that were reported and fixed. And I had started sort of tracking cumulative counts, but then sort of fell by the wayside, and wanted to kind of pick back up that that tracking and actually look at some patterns that we've seen over the years, and then talk to 3 different groups about this data. So I already talked to the chairs and leads meeting, went through this data with them to try to help the people who are sort of on the ground reviewing designs and features and pull requests, help them see some of the patterns that we're seeing so it can inform the decisions they're making and the reviews they're doing. Then I wanted to talk to SIG Arch about it, just to kind of get an overview of sort of where our quality levels are at, and some trends that we're seeing, and maybe let it inform some tweaks to PRR stuff that we look at. And then next week or the week after, I was going to take this to SIG release and get their help from the branch managers in sort of maintaining the data of backports that are going in. I mean, don't get me wrong, it was an enjoyable weekend sweeping 300 pull requests and making sure they were all labeled and release noted. But it would be great if that could be sort of a regular part of the process. When we take backports back, we should be answering the question, is this a regression, fixing a regression? And if so, when was this regression introduced? So we can put those in release notes and things like that. And then another thing I'm going to be asking SIG release is whether some of the things that I noticed here should inform our backport policy. And I'll get into that in a little bit.
Okay, Jordan, like just a quick question going in. Like, so this is not regressions introduced by backporting. This is a regular course of business, and we
have some of both.
We have some of both. Okay.
Yeah. Most of the regressions come in with the .0 release.
Yeah.
But there are, well, we'll get into that. There were a dozen or so that came in with patch releases. So
okay.
All right. So first, just to sort of explain what this table is, it makes a lot of sense to me because I made it, but I realize it might not be obvious immediately. Each column is a minor version. So we've got 119, 120, on down the line. Going top to bottom, this is tracking the months since it got released. So this is the first month after release, second month, all the way to 14 months. And I started with 119 because that was the first version where we had a 14-month support cycle. Prior to that, it was like 9 or 10 months, and I kind of wanted to compare apples to apples. So I could have gone back further, but 119 was when we started the annual support cycle. And so then the numbers are the cumulative regression fixes that landed in that release branch. So you might think, oh, like 119 got really bad by the end. In reality, I think most of these issues were present in 119.0. We just discovered them very gradually and sort of fixed more and more and more and more issues as the release went on. Similar with 122, you see the number sort of growing all the way to the end of the support window. And there are other releases where that number flattens out. So 124, you ended up with 11 or 12 regressions that got fixed. And the majority of those had already been discovered and fixed sort of halfway through the life cycle. So this was a pretty flat curve. And then once you start to get to 125, 126, 127, obviously we haven't finished the 14-month lifetime for those releases yet. So we don't actually know how good they're going to be by the end compared to some of the others where we have the full set of data. So that's kind of how to read the numbers here. And then to try to give us some sense of comparison, like relative to other releases at this point in the release life cycle, I sort of took the min and the max and the average, or the median, 1 month after release, 2 months after release, and so on. And so 1 month after release, you can see the worst release we had, we'd already discovered 6 regressions and fixed them. The best one, we hadn't discovered any, and the median was 3. And so things better than the median are green at that point in the life cycle, worse than the median are red. All right. And one more thing before I jump into some of the analysis information. So one interesting pattern that we see pop out is regressions getting discovered when the next release comes out. So 126 looked pretty reasonable, or pretty good actually, for the first few months. And then like 4 to 5 months in, 127 got released. And as part of releasing 127, we enabled some stuff server side and discovered client bugs that had shipped in 126. And so there was a jump from 5 to 16 regressions fixed in a couple of months. And most of those were things we discovered as we were releasing 127. So that's sort of one pattern to look for. If you see a jump about 4 months out, that might be something that got enabled or exposed by the next release. But then actually, since that point, since we sort of fixed that flurry of regressions in 126, 126 has been perfectly flat. So I'm hopeful that by now, 9 months out, it's actually back into median territory. So that's good. It's a good sign that it flattened out. Anyway, I'm happy to take suggestions for better ways to visualize this. It's kind of having a hard time figuring out how to show, like, allow comparisons and show the story of what was going on. All right, so any questions?
The question on the chat.
Where is chat? Can someone read the chat?
Yeah, I can read it. Does each Mark? Why don't you?
Yeah, go ahead. Yeah. No worries. So basically, each issue, is this a separate PR, or is this a separate, like?
Yeah,
some of these 3 PRs for the same
level.
issue?
It's the PR level right now. So this tab has sort of the raw data, and it's not super smart. It just sort of looks at the release date and then builds queries that show, pull requests labeled as regressions. Oh, did I pick one that had 0?
I got it. Okay.
Oh.
So some of these may be like multiple PRs addressing the same issue, but in general, probably one per issue.
Yeah, I think so. We already have the ability to pull multiple fixes into a single backport PR. So if there were like a couple different commits or a couple different PRs and both were required to fix regression, we generally always, as far as I'm aware, would backport those as a single PR. And so if we have multiple PRs going back, getting labeled as a regression fix, I think it's actually fair to count those as multiple issues.
Yeah, it makes sense. Cool. Thanks.
Yeah. Hi, Jonathan. One question about, is there any data showing how long does a regression gets firstly fixed since it's getting introduced? Like how many releases since we spotted the regression and get it fixed? Is there any data?
I didn't compile that yet. We could certainly get that information from the pull requests that are labeled. One of the things that I did as I was going through, see if I can find some examples, was to be specific about when the regression got introduced. So this one was the beginning of 122. All of these might have been 122. If it got introduced in a patch release, then I put the patch release in the release note. So we could gather the information about when it got detected and how many releases after it got detected. I think that would be a great thing to look at.
Yeah, thank you.
But I didn't yet. I'm trying to follow the chat.
Oh, we are just having fun there.
Okay.
I mean, it is pretty easy to recolorize this and say, when do you have 90% of all regressions? But if we all do that.
Yeah, like flipping this around and saying like there were 33 regressions present in 119 and how fast did those burn down? That would be another useful way to visualize this. All right, so I wanted to call out a few patterns that I saw. One I mentioned already, where there were client issues that shipped in 126 and then got exposed in 127. Let's see. 122 and 127 both had some kubelet pod lifecycle fix-ups, and those tended to be well, 122 especially, we don't know for 127 because we're not at the end yet, but there was a long tail of discovering edge cases that had regressed in kubelet, in 122 at least. We'll see what 127 does, but that showed up in 122 and 127. A few places where we switched one long-lived thing to another long-lived thing. So when we switched from endpoints to endpoint slices, there was a period of 3 or 4 releases where we were enabling a controller and then enabling another controller to translate sort of custom endpoints over to endpoint slices, and then enabling kubeproxy to use endpoint slices. And there was a sort of steady stream of edge cases that we found where validation wasn't quite the same, or one type of custom endpoint didn't get translated to an endpoint slice correctly. In general, switching an existing long-lived thing to a new thing that is supposed to replace it is where I saw sort of the most regressions. So switching kube control from using OpenAPI v2 to OpenAPI v3, there are a bunch of edge cases, and if it was a net new thing, you could just turn off the feature. But if it was an old thing that used to work one way and the new thing needs to essentially match its behavior exactly, that wasn't as easy to switch off. Switching from old discovery to new discovery, and switching from endpoints to endpoint slices. Those were just 3 examples where I saw multiple issues, people saying, I have a weird server that returns this type of OpenAPI thing, or it excludes this, or it's just sort of returning stub data. And yeah, so this was something, especially when talking to the leads about, like, if you're doing a new feature, it's pretty easy to just gate it and say, like, if there's an issue, just turn off the new feature. If you're switching an old thing to a new thing, that can be harder to recover from.
So
And then, oh, go ahead.
we didn't have anything blow up with the Docker shim one in 124. Yeah, I don't see. I mean, it looks green. 124, 125. So and that is one more long-term thing, right? Like a lot of people were using Docker through Docker shim, and then we totally cut it off.
Yeah, I think there probably wasn't a, we probably didn't see 100% of usage switch from Docker to CRI in 124. Like people had already started switching over. So 124 was the final burn down.
Right.
But people had started switching long before that.
Yeah.
So it was probably smeared over multiple
releases. Okay.
And then the other sort of category was bug fixes in areas where the complexity isn't matched by test coverage. So the kubelet pod lifecycle stuff is the biggest example. There's actually another maybe 2 or 3 issues that just cropped up around stateful set handling. So we're trying to untangle that, and but we haven't actually figured out the fixes for those yet. So as soon as we do, more data will show up here, and that might be another area that gets added. But this isn't surprising. Like if we make changes in an area where we know we have a lot of complexity and not a lot of test coverage, it's not surprising that we regress, but this puts specific data around those intuitions around the kubelet stuff.
Right. The sidecar one also, we fixed a regression just a couple of weeks ago, right?
Yes. Yeah, so that I talked about that a little bit below. Someone had the question, was that you, Dims, whether these were regressions in the .0 release or in patch releases? So most of the regressions were in the .0 release. It was something that happened during the normal development process.
Okay.
These were ones, so out of all of these in the graph, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, maybe a dozen were fixed and then backported, and the backport itself regressed something. And so the places where I saw this happening the most were API Machinery and Node. Scheduler had one, and then like I mentioned, there's a stateful set one we're working through, so apps might have had one as well. This isn't to say API Machinery and Node are the worst at this. I think they just have the most backports. So if you took them as a percentage of their backports, I don't think it would be much higher than other SIGs. API Machinery and Node just own a lot of code.
Yep.
And so there are a few things that I am trying to think through and we'll be talking about with SIG release. One question for SIG release is, should we reconsider our policy of saying if you backport anything, you should backport it to all release branches simultaneously? For something that's fixing a critical issue, you know, a data loss or security issue, or a regression, fixing a regression, recovering as quickly as we can in all the release branches, I think makes sense. For something that is more just a nice to have bug fix, taking it back to all release branches simultaneously means that if it regresses anything, we have regressed all our release branches, not just the more recent ones. I'm not really sure what I would recommend, but
yeah, then the question becomes like, okay, which one did we backport, which one did we not? Like,
yeah, if we don't do it simultaneously, tracking becomes a lot harder.
Absolutely. Yeah.
Which is not great, but I also we also really, really need our patch releases to be no-brainer. Like if people learn that patch releases can regress them and regress them occasionally, regularly, quasi-regularly, we will have a hard time convincing people that patch releases always make their life better and they should apply them regularly and without, well, yeah.
What percentage are we actually looking at? That seems worthwhile to have a conversation with SIG release. If you're looking at 10% cause regression, well, yeah, we have to do something.
Yeah.
If we're looking at 1% cause regression, still not good, but
I guess I would look at like
how
how many of the patch releases got regressed. If we backported 100 things and 7 caused regressions, like, okay, that's 7%. But if those 7 caused regressions in 7 patch releases in the same minor, then that's like 50% of the patch releases in that minor. So 121.1, 121.2, 121.3. I don't know.
I'd be interested in seeing both numbers, but
yeah.
I think both are useful to be able to have a discussion that isn't just fear-based.
Right, and then the flip side of it is hardening the cherry pick policy, right? So this could be an input into the cherry pick policy to say, okay, there are some things that we are not going to go back, and we're going to stop at 1 or stop at 2, and not all the way back.
Yeah, I don't have a very quantitative way to measure what would be good to take back all the way at this point. Patterns for things I noticed that caused regressions when they got backported. Big changes, I forget which one it was. I think it was this one. So this one started out fairly big on master, and I have no doubt that it was fixing a problem that was a significant problem. So that's the hard thing to weigh, right? The known fix against the unknown risk. But then by the time it got all the way backported, I think there were a lot of other things mixed in that also had to be backported to avoid conflict. So by the time it got back to 125, it was like twice as many commits, pulling in stuff from 4 or 5 different PRs. Yeah, I think, go ahead.
Yeah, I think that brings up conversation or coding principle is that make the regression fix as minimal as possible, as cherry pickable as possible, because some like refactoring thing can be a follow-up, especially for regression fix. I think in SIG scheduling, we are following this principle pretty well. When we're doing regression fix, we keep the principle of cherry pickable as the first.
Yeah, so in this example, it was picked back 3 minor versions. So if we're recovering from a regression in the most recent release, then yeah, we probably haven't stacked that many refactors. Code may not have moved that much. We can probably craft a minimal thing. By the time we are 2 or 3 versions later, it's often the case that there's a whole stack of things that are between us and the version we're trying to backport to. And then the question becomes, like, is it even a backport anymore, or is it new development where, you know, we're merging a handcrafted different thing back to the release branch? Anyway, so big changes are something to watch out for, and these were things that I was going over with the leads as well. Like, I see that finger down.
Jordan, for big changes, like there was one more thing which was really big, like the vertical autoscaler, that didn't seem to have caused issues from what I can see here.
Well,
it's good news, I guess. But
vertical autoscaler was feature gated and hasn't been enabled yet, and we don't backport changes for bugs in alpha feature gated things.
It was still a lot of code, and it still made a lot of changes to, even if it was feature gated, I think.
Yeah. I think there were a couple last minute fixes around that, but I don't start counting regressions until we've released the .0.
Okay.
So I think it was between release
That's
cancer.
fair. Yeah, that's fair. So it might have cost, but we caught it before the .0. Yeah, we don't have that counted here.
Yeah. Another pattern that I saw was partial changes. So this was actually a pretty isolated change. It was to honor integer types. And so, it's a pretty targeted change to the JSON decoder and YAML decoder with good unit tests. But there were other changes in the API machinery decoding stacks that had to adjust to getting these types in their unstructured objects, and we didn't realize that those other changes were required to be backported as well. And so, just backporting this, like you would look at it, looked pretty inspectably safe and had unit test coverage and everything, but there were a lot of other things in the stack that had changed in parallel, and so that exposed an issue in I think it was in custom resource validation. So partial changes, and then the last category was changes that break people who use our things as libraries. So you can write custom scheduler plugins or aggregated API servers that do things that we don't do in Tree. They might have Go types that aren't directly comparable, like have private fields for their API types, or the custom scheduler plugin might be exercising aspects of the scheduler that the plugins we have in Tree don't. And so there were several places that a backport actually worked fine for all of the Kubernetes binaries, but we got reports from someone updating to use the libraries from the latest patch release that we had broken their aggregated API server or broken their scheduler plugin. All right, so I did want to call out a couple things that I thought went well, and then a couple things that maybe we could think about from the SIG Arch perspective, like if the current PRR questions or process encourage people to give mitigation strategies for these types of things. So one of the things that went well, SIG apps had a feature around job tracking that added finalizers to pods and then removed finalizers so that we wouldn't lose track of them before the job had recorded the pod termination result. It went beta, and then several issues got reported with pods hanging or the controller hanging, or there were just several different issues because we had a feature gate protecting the whole thing, and because PRR had asked about, is it safe to enable this feature and then disable the feature and then enable it again? Like, it asked those questions, and so the apps folks had thought through those enablement, disablement, re-enablement flows. We just turned the feature off in 123 and 124 and recovered at head. So even though 4 or 5 or 6 distinct issues were found, we were able to quickly restore 123 and 124 to sort of status quo working state and not elongate that trickle of regression fixes. Again, that was only possible because there was a feature gate around the feature and because it was largely sort of an internal bookkeeping feature. It was really just how the controller kept track of pods. And so if you turned off this feature, the controller went back to tracking job pods the way it always had. There wasn't really any user interaction with the feature. So it was great that that issue could be mitigated with a single backport, and then we could recover at head. A couple specific things that didn't go great. One was the sidecar feature that you mentioned, Dims. So there was a feature gate around the sidecar stuff, but there was a refactor to kubelet code that was sort of done as preparation for the sidecar feature that wasn't gated. So it was a preparatory refactor, and it did not preserve behavior. And so that just happened in 128, and it broke init containers. and the feature gate wasn't usable to recover from it. So this was something I was talking about with the leads, like refactors are changes and they can be scary as well. And so if you're doing a big refactor that is only for the purpose of a feature, consider making two code paths. One is the current code path and one is the refactored one, and you only take the refactored one if the feature gate is on. That's not always possible, especially some of the kubelet stuff in 122. I was talking with, I forget who, maybe John. He was asking, like, could we have feature gated the kubelet refactor in 122? And I don't actually think we could have. So I think that the answer for kubelet in 122 was probably better test coverage of like the static pod and pod admission stuff before we changed anything there.
Yeah, the cherry pick that we did just now for the 129 back to 128 also like picked up a bunch of code from 128, resurrected it, and then we did something like that, right?
Yeah, the fix for the sidecar basically just copy pasted the the old code, the 127 version of the kubelet pod lifecycle calculation, and then said, we're going to use the old version unless you have sidecar feature turned on. Yeah. That was like a single function, so that was pretty easy to do. Once you start threading through a bunch of different layers, it's really hard and actually maybe more confusing and error prone to take different paths depending on feature gates. But it's something to consider. The other sort of low light was the client issues that shipped in 126. So there were two things here that I think are pretty important to realize that I don't think we've done a good job of signal boosting. One is client-side fixes are essentially impossible to ensure they get picked up. So we shipped 126.0 with a client bug. We actually fixed that client bug in like 126.4, I think.
3.
But if you look at like the internet, a
Hey.
lot of the internet is still building with client Go versions before 126.4, including us, right? Like not even we keep our client libraries up to date. So the way we operate, where we do the best we can, test as well as we can, and if we find issues, we fix them and backport them in patch releases. Like that's mostly okay. Like we want to do better but that sort of works for server-side components, but it doesn't really work at all for client libraries. Like until the end of time, there will be things built with 126.1 versions of this.
So it was funny for this one, even though we had merged a fix and like we had closed the issue saying, we didn't have an issue, I think. At that point, somebody had found the fix and like did the PR and we closed it. We didn't have a tracking issue. So I ended up creating a new tracking issue after the fix was merged and like collected links from everywhere. Like I got like 10, 12 links at that point.
Yeah. So the mindset around .0 releases for any changes we're making to client-facing stuff needs to be different. Like we need to be very resilient. So a lot of the fixes that you see going into 126 were of the flavor like try the OpenAPI v3, and if there's any error, fall back to OpenAPI v2. Try the aggregated discovery, and if there's any error, fall back to old discovery. Especially when we're replacing an old thing with a new thing, we need to be very, very conservative about falling back to the old thing, especially in client stuff. And then the other lesson on the client side is we need to have like opt-in and opt-out mechanisms. And so we've been trying to think about like ways to do this. The feature gate mechanism we have doesn't really map super cleanly, but there are environment variable based mechanisms that kube control has used that we might be able to sort of mimic in client Go. But we can't just say, oh, feature gates don't really work for client stuff, so I guess it'll just be on by default with no opt-in and opt-out. All right, I've been talking a lot. The main question that I had for SIG Arch was, Are there things that we see in here that we think we should pay more attention to in the PRR process, either with specific questions or specific things for the folks doing the PRR reviews to pay attention to?
Can I get one counter question first?
Yep.
I recognize at least some of these, and they correspond with skew problems. Now, skew is not precisely PRR. There's been a long-standing section of how do you handle version skew inside of a KEP. And I'm wondering if that's a thing we should start trying to test, right? To actually say, when I run old controllers against new API server, does it work? Because that combination, old controllers, old kubelets, they would be running the old client code. And if they malfunction, we do know that it's a bug.
We do run kubelets all the way back to n-3 against the current API server version. So we run n-1, 2, and 3. Kubelets, though, don't exercise a lot of the more interesting parts of client Go. They sort of know that they watch pods and they watch config maps and secrets, and they don't really use discovery. They don't really use REST mapping. They don't.
Controller manager does, though. So, for instance, depending on the failure mode, I believe the aggregated discovery one was actually if you aggregate an aggregated API server that's malfunctioning. But wondering about these others, when you say we ship a new version and then we see regressions in the previous version, it sounds a lot like skew.
I think it was feature enablement more than skew. So like the aggregated discovery enabled in 127 server side. So during the 127 dev cycle is when we discovered the issue in client Go and fixed it.
Wojtek?
Yeah, I think I have a couple thoughts. Like the version skew, I think I'm with Jordan. It's not. It's more related to feature enablement. That said, I think that like I'm personally reviewing pretty carefully the version skew and the like upgrade downgrade strategy and so on. And I'm wondering if we maybe should consider moving it also under PRR so that like we actually officially review it. That's the one thought that I have. The other thing is like regarding the first part, which is like refactorings, big changes in the code. I think that is not very actionable for PRR. I mean, I think it would require understanding not just the design very well, but also like what exactly will be happening in the code, which is impossible if we are doing like 15 or 20 caps within a week or something. So I'm afraid that isn't very actionable. I'm not sure what we should do. I think we should basically rely a little bit more on like code reviewers and code approvers for this particular thing.
Yeah, for refactors, like making judgment calls about whether a refactor should be gated. Like that's why I was talking with the cheers and leads.
No, I think I got your point, but like I've seen at least some cases, or in particular, Sidecar was the one that I was reviewing from the PRR perspective, and I think at that like at the level of like when the CAP was reviewed for alpha for PRR, I think it wasn't even fully clear how much refactoring will be happening and where exactly and so on. So it's I'm afraid that I will think about it more, but I'm not sure if there were things that we could really do visibly better here.
The main thing that I was wondering about in PRR was asking about mitigations for client-side stuff.
Yes, and this is the third thing that I wanted to mention. And for client-side part, yes, I think we should think what kind of question, probably in the like feature enablement, disablement section, we should add and basically try to add.
So Jordan, I know you and I have talked about that before. I would like to find something. I think we owe the creation of a pattern to actually do it. Because we are trying to find a way to disable, to allow people using a binary they did not compile to disable a feature that the library user did not consider or even think about in a way that will usually work. And so that is an even broader problem that happens in kube control. I am in favor of doing it. I think we need to think of a way that is tolerable. And mvar sounds pretty good, but even an mvar needs to be opt-outable if it causes problems for the binary, depending on a library. There are few things I dislike more than a library doing some global thing to my process that I cannot fix. So I'd be happy to help enforce that and help create that. I think that we need it in API machinery in 129 or whatever release we bring CBOR into. I think it's going to be critical to have that mechanism. So perhaps trying to work it out on that PR, or that enhancement.
So I know we've been talking about what can we do in PRR, but I do have a question that I would like to ask the folks here, which is not related to PRR, but it is about like the health of the approvers and reviewers in the two SIGs that we were talking about earlier. So do we have a healthy set of people doing the code reviews for and approvals for API machinery and SIG node?
I mean, I do a lot of reviews for API machinery. Some of the ones that I liked to were things that I reviewed.
I wasn't gonna throw people under the bus, but I think if you do look through the history, we've all made mistakes.
Yeah,
it's not the mistakes as such. It's sometimes it could be because for example, SIG node, I think we might have a queuing problem with respect to the number of things that get bunched up towards the very end, right?
Yeah, I think a mindset shift of like, I don't see anything obviously wrong with this, so it seems okay. Like shifting that to this is demonstrated to be safe. Like we just want to make sure that we understand the changes that are going in, especially that we understand the changes that are getting backported. But even the things just merging to master for a new release, we need to understand the changes that are going in. Even since accumulating this spreadsheet, it's changed how I'm reviewing some backports. Like I'm asking a lot more questions about like, do we understand all the call sites that lead here? And are we sure that this is equivalent to that? And so, I mean, API and machinery and Node have a lot of code and a lot of reviews, like trying to encourage the reviewers and approvers to have that mindset seems like a good thing to do.
Yeah, there's nobody from SIG node here. We need to take it out back to them and show them this data. Did any of the SIG node approvers came to the leads meeting, Jordan?
I have gone through this so many times with different people. I can't remember which meeting it was, but I have talked to some of the Node folks about it. Yeah.
Hi, Sergey.
Oh, hey, Sergey.
Yeah, hello. I was listening mostly. Yeah,
Yeah,
I mean,
oh,
we have so many tech debt right now. It's hard to. I mean, we cannot just stop doing anything before we fix all the tech debt. That's why regressions will happen.
Yeah.
yeah, we're not talking about stopping everything. It's more like the thing we need to have a do no harm mentality. Like if we're going to change something, we need to understand what's going through that spot to a responsible degree. And yeah, like perfection is probably not attainable. That's why we want ways to mitigate things, feature gates and opt out, and we need ways to mitigate things. But knowing when we are making a big change or a change to a complex area and making sure that the change is well understood and matched by test coverage is, I think, what we're shooting for.
Yeah, specifically for sidecars, we've been struggling with this decision of whether hide all the new logic under feature gate. Sorry, I interrupted many hands, but let me reply first. Respond first. So we've been struggling, like there is a node pod life cycle change that we needed to implement, and one option was to basically duplicate the whole file and have one version with feature gate and another version without feature gate, and we decided not to go this route. Mostly because, I mean, after we discovered the problem, we put even more logic under feature gate. So now there is duplicated logic that is not very pleasant. And the main reason for that is we added a lot of tests. We went through many reviews, and we assumed it's safe. The real danger here is we can go with the feature gate disabled till like in alpha, and then nobody will even discover the problem. And then when we go into beta, like you suddenly get like all the new logic everywhere, and it breaks everything more in more ways than before. So
yeah, but I would still take something that had a feature gate wrapped around it that I could just turn back off. Yeah.
Okay, we got to get to the queue. David.
So one thing I was going to mention is that I know there's been some focus here on refactors. I know some people look at refactors and say these are by definition optional changes. We should not refactor. We should focus on stabilizing with whatever shape we have. I strongly disagree with that. I would like to be sure that an outcome of this is not that we dissuade refactors. I don't want to dissuade projects that are going to improve future maintainability, even if it causes some potential short-term pain. I am open to trying to find better ways to structure them. So structuring a refactor behind a feature gate and saying, I'm going to replace an entire component at once in order to do this, completely fine with that. But I want to be sure we don't come out of this with an attitude of the threshold to refactor is higher than SIG thinks it will be better on balance in a year if we make the change. So
yeah, I agree with you there. It's just that, like, for kubelet, there have been people have put in PRs for refactoring, and we've always told them, hang on, don't do it. Let's do it for a reason, right, Sergey? We've told people a few times to like hold
I
off on.
don't intend to tell the SIGs how to do it. I just want to be sure we don't end up in a spot where it's, oh, we're too afraid to refactor because we're going to get blamed for a regression. I will say, I think, Jordan, if you have thoughts on how to structure refactors, I believe Stefan is working on a very significant set of refactors right now, and getting up with him about the manner in which you would suggest they happen is likely to be helpful. He's talking about refactoring the way the Kube API server is layered and built. So it is both large and foundational.
Yeah, the ways that I've seen big refactors go best is when there are small steps that you can fully understand and see are equivalent, and then you make a series of those small steps instead of sort of one big step where you're juggling like 24 inputs and outputs and call sites in your head to try to make sure
there's no disagreement on my part. Just I know that it will be coming up in the not too distant future.
Mo, we have 7 minutes.
Yeah, I was just gonna mention quickly, like, I guess I would push back a little bit on like we can't stop, because like if I take like the recent OIDC work that SIG is doing, I didn't let that work start until we basically wrote an entire new integration test suite for it, because the code was so old that it lacked the appropriate coverage. And I was just completely uncomfortable with futzing with it in core ways without putting strong guardrails to make sure that we just didn't break it randomly. And that took a long time, but now we can make changes to it without wondering, did we just host the whole thing in some subtle way that we didn't notice? And yeah, like our integration tests are almost like unit tests. They do really probe at a lot of the core functionality in a way that you might not do in an integration test. But like, if I go change a thing, I know it's going to break that integration test, so I know we're covered. And then also, I think, Jordan, you appreciated that I like made sure all the initial changes were very carefully put in a way that they would not break anything or change anything at all, but were still reviewable in sort of like a targeted way. But I don't know if that helped or not. But
I think both of those are good examples of what we're looking for, like making sure test coverage is there first, and then doing a refactor in a way that is inspectable and like small steps that you can see all the inputs and outputs to. I think Sergey's point was more like we wouldn't say we're not going to change anything anywhere in SIG auth until we have test coverage of the OIDC thing, right? We would wait to make changes to the OIDC thing until we had test coverage for it. But like the components are big, and the code the SIGs are responsible for is big, and sometimes you need to make changes in one area even though another area has technical debt.
Jordan, can you give a talk at our contributor summit?
Yeah, it's already submitted.
Oh,
this
good.
is
Thank
on there.
you. Yeah, ahead of me. Thank you.
All right, so the couple AIs that I heard, I think David's point about skew tests is well taken. I can check and see if we're doing skew tests with Q control. I think there are jobs, but I don't know how much attention we pay to them. I know we test kubelet skew. I don't think we test controller skew at all. So I can take an AI to see if it's possible to run at least a one version skew job that would exercise the controller skew. The other one was coming up with a pattern for client enablement, disablement, opt-in and opt-out of a change. So it sounded like David was interested in working on that. I would be as well.
Yes, I am. I'll sketch something out.
Okay.
And if someone else is interested in reviewing as well, I'd be happy to share there. Otherwise, it'll come up at API Machinery.
Yep. And once we have a pattern there, then folding that into the PRR stuff, just like we do with feature gates. Say, oh, looks like you're making a client library change. Would you like to add an mvar or whatever mechanism we come up with? All right, thanks, Bartek. That is all I have, and I think this topic took our whole meeting, so that was longer than I expected.
You aim for 20 minutes, Jordan, based on that item. But thank you for doing this. Any questions from anyone? Okay, 1, 2, 3. Thanks a lot, everyone. See you in 2 weeks.